Bismillahir Rahmanir Rahim. Hello everyone. Welcome back. Let me first wishing you all the best, and I hope all of you are safe and healthy. We will continue our course, and this is face-to-face lectures in which we are going to discuss the properties of matters, and we are dealing now with chapter 20 in which we are discussing solid state matter. The outline of our lecture today will start with an introduction to the state of matter. What are the state of matter? A brief summary about them, and then we start to talk about what is a solid and the crystal structure of the solid. And solid could be described in terms of density and elasticity, and then we ending by discussion about tension and compression. For the introduction, there are mainly three forms of matter: solid, liquid, gas. And we call this state of matter, as we mentioned, it could be transformed from one form to another, either by cooling or by heating. Let us discuss what are the difference between these three states of matter. From the molecular point of view, the solid state always have high, tight bonding between the molecule each other. Where for the liquid, it is slightly apart, the molecule is slightly apart from each other. And for the gas, they are far apart from each other. And this will reflect on their volume and shape. For the solid, it will have a fixed volume and fixed shape. For the liquid, it will have a fixed volume, but the shape, it will take the shape of the container. For gas, it will have no fixed volume and no fixed shape. It always take the shape and volume of the container. So according to NASA, we can summarize these three states of matter. The solid, it holds its shape, it has a fixed volume. For the liquid shape, it will take the shape of the container and the surface are free surface, and it will have a fixed volume. For the gas, the gas always take the shape of the container and the volume of the container. Solid state matter. Humans have been using solid material for many thousands of years. The term Stone Age, Bronze Age tell us the importance of solid material in the development of civilizations. Solid quite often exist in form of crystal. As an example of the solid, metal, salt, and most mineral, all of them are made up of crystal. What is crystal? Crystal are regular arrays of atoms, atom being arrays in these forms. How do we know the form of the crystal? We can use X-ray diffraction methods by which the photograph produced by the diffraction method can tell us what are the distance between the atom through the crystal. So distance between the atoms and the crystals could be determined by analyzing the pattern of diffraction for X-ray. Crystal structure. we will try to get the crystal structure of sodium chloride atom, the salt. So the radiation that penetrate the crystal could be shown in the photograph's film beyond the crystal. The white spot at the center is caused by the main unscattered radiations here. The size and arrangement of the other spot indicate the arrangement of sodium and chloride atom in the crystal. All crystal of sodium chloride will produce the same photographs, the same design. So this is a design of the crystals. In this model, sodium chloride crystal here, large sphere representing the chloride ions and the small one represent the sodium ions. We can know the interatomic distance between them from the diffraction pattern of the film of X-ray. Now let us go to another property of the solid, density. Question: is iron heavier than wood? Answer: obviously, it depends on the amount of iron and wood concerned. What is density? Density is the amount of mass occupied a unit volume, right? It could be calculated using this equation: density equal mass divided by volume. And the unit for the density could be kilogram per meter cube in SI unit, or could be GM, gram per centimeter cube in CSS unit. For example, what is the density of water? Density of water is 1 gram per centimeter cube. This is in CGS system. But in SI system, the density of water is 1,000 kilogram per meter cube. If we have slice spread here, if by accident put some press on it, the volume will reduce. When the volume will reduce and the mass is the same, the density of the bread will be increased. For the density will depend on physical parameter. The first one, what is the mass of the atom? The mass of the material will depend on how much the mass of the atom contains this material. Second one, what is the spacing between the atom? Because this will determine how much volume the material will have. So the density will depend on the mass of atom and the spacing between the atom, mass and volume. Density is a property of the material. It does not matter how much material you have. So to explain this a little bit further, let us have this question: which has a greater density, a cup full of water or a lake full of water? Obviously, in both cases, they are water, and water have fixed density. So both of them have the same density. Obviously, the ratio between mass and volume for the cup is exactly equal to the ratio between the mass and the volume of the lake. So both of them are water. Both of them have the same density. This is a table showing density of common substance for solid and liquid here. The density is being expressed in kilogram per meter cube. It also could be expressed in gram centimeter cube if you divide it by 1,000. Why that? We noticed that 1 gram per centimeter cube is equivalent and equal to 1,000 kilogram per meter cube. So in this case, the density of gold, which 19.3 10 to the minus 3 gram per centimeter cube. It is 19.3 times more the density of water. Let us have some questions. When water freezes, it expands, it will increase in volume. So when we compare the density of water with the density of ice, which one has more density? Both of them have the same mass, but they have different volume. And as we explained, ice have more volume than water. So in this case, ice have less density than water. Okay, now, which weighs more? A liter of ice or a liter of water? Think about it. When we say weight, how can we get the weight? Weight equals mass times gravity. And for the mass equals volume times density. So if the density of water greater than the density of ice, then the mass of water will be greater than the mass of ice. And accordingly, the weight of water will be more than the weight of 1 liter of water will be greater than a weight of 1 liter of ice. Again, another question. What is the density of 100 kilogram of water? The obvious answer that water have constant density. It doesn't matter about the quantity. So the density of water here is just 1 gram per centimeter cube or 1,000 kilogram per meter cube. Question, which has greater density, kilogram of leads or kilogram of feathers? Kilogram of leads, kilogram of feathers, they both have the same mass, but obviously the volume are different. So I'll let you answer these questions. Now we go to another property of the solid, is the elasticity, al-muruna. We all know that when a material is subjected to external forces, it undergoes changes in size or in shape, or both of them, size and shape. When the forces are removed and the material returned to its original shape, we said that this material is elastic material. But when the material do not return to their original shape, we call this material inelastic material. Obviously, the change happening will depend on the arrangement and bonding of the atom in the material. For example, this baseball ball, it is an elastic material. When the force is hit it will be deformed. If the force is removed, the baseball will return back to its original shape. For the material which has elasticity, if you stretch the spring, it will expand. And this expansion, it will be directly proportional to the applied force. So what happens if the weight is double? So if the weight is double, the spring will stretch twice as much. We know that the force will be directly proportional with the extension here. More forces, more extension. This is famous Hooke's law, that the extension of a spring is directly proportional to the force applied to it. Force directly proportional with the extension. With that fact in mind, let us try to answer this question. If a force of 10 Newton stretched a certain spring to a length of 10 centimeters, how much stretch will occur for an applied force rather than 10 will be 15? What is the answer? I'll leave you to answer this question. Another question. Which is more elastic? Is it steel or rubber? Please think about it. We are going to have the answers. If the steel is more elastic than rubber, the first answer comes to our mind that obviously it will be the rubber. Rubber is more elastic than steel. As a matter of fact, if we think about it, this is not true. Because rubber, if you increase the strength on the rubber, yes, it will stretch, but at certain point it will break down. It will not come back again. But for the steel, you can apply more and more stress, and it will extend more and more. So the range of elasticity for the steel will be greater than the rubber. So the answer for this question that steel is more elastic than the rubber. Another question. If we have 10 centimeter long initial length of spring is 10 centimeter. This spring extends to 12 centimeter when we apply 1 kilogram load. What would be its length if we apply, rather than 1 kilogram, we apply 3 kilogram load? So which answer which we're going to choose? We know from the given value that 1 kilogram will causing a 2 centimeter stretch. It is originally 10 centimeter. It will become 12 if you apply 1 kilogram. So when you apply 3 kilogram, the extension, the stretching will not be 2 centimeter, it will be 6 centimeter. In addition to the original length, which is 10 centimeter, so the answer for this quiz is 16 centimeter. Now let's talk about tension and compression. When something is pulled means that will cause the atoms to be stressed out. It will spread out, and will cause tension, right? But if you squeeze the material, together, the atom will come near and near each other. It will be shorter, and we call this compression. So for tension, the atom will spread out. It will increase a little bit in the length. For compression, the atom will squeeze and it will decrease in the length. Now let us see this example here. When we have a beam of steel, it will be fixed in the wall in one side, and we put load on the other side. So what happened in the upper side of the beam and in the bottom side of the beam? What we notice here that the upper side of the beam will have tension because the atom there will be stretched. It will increase a little bit in the length. So will have a tension in the upper surface. For the lower surface, you noted that it will be shorter because a compressions occur and the molecules come nearer and nearer to each other. And you have line in the middle in which you have neither extreme tension or compression. This is a neutral line. What happens when we fix the beam from the two ends of it and we have a load in the middle? In this case, the tension will be in the lower surface of the beam and the compressions will be in the upper surface. And again, we have the neutral one in the middle. Now we can explain why the steel I-beam is commonly used in construction. And the all civilizations, when they have building a temple, always the beam take the form of I shape because it is light in weight and has nearly the same strength as solid steel bar. So when the beam is used as shown in figure here of the shape of I-beam, when it's been used for construction, actually it will have maximum strength. It will have tension on the top part, and it will have compression in the bottom one, and the middle part is neutral, has nothing, no tension, no compression. So it will have maximum strength because the top, it will be under tension, the bottom will be under compressions, and have the most material there. But at the same time, it will have minimum weight. This is empty, it has no material. So because the middle of the beam that is not under stress has the least material there. And we matching this from we have the femur's bones in our body, which is in the legs. It had the job of carrying weight there, a lot of weight actually. So Allah subhanahu wa ta'ala make it take the shape of I shape. For the same reason, it will give us maximum strength and minimum weight. Question: which position of the I-beam would support a greater load of this? And why? Let us discuss it. Think. If you have a tree, and if we make a hole in the horizontally through the tree branch here, which location of this will weaken which location weakens it in the least? The top, the middle, or the bottom? The top, the middle, or the bottom? Think about it. The answer here is the middle. Why? Fiber in the top part of the branch are stretched, and fiber in the lower part of the branch are compressed. In the neutral layer in the middle, the hole will not affect the strength of the branch. Now, let us have some assessment questions. Question: the crystal that make up mineral are composed of, this is 4 options. The first answer is composed of atom with definite geometrical arrangement, or it composed of molecule that continuously move, or it composed of X-ray pattern, or it composed of 3-dimensional chessboard. Think about it and give me your answer. The answer is A. Another question: if you hang by a tree branch and note how much it bends. Now, when the hanging, when the force, when the press will be twice the weight, twice, what happened? This will produce half of the bending. This will produces the same bend. If it's a branch doesn't break, will normally produce twice the bend, or it will bend the branch 4 times as much. Think about it. The answer is C. If you hang by tree branch and know that how much it bend, then if you're hanging with twice the weight, normally it will produce twice the bend. Another question: when you bend the branch of the tree, one side of the branch is under tension, while the other is under compression. Both sides of the branch are stretched. Both sides of the branch are compressed. The branch is a neutral state. Which one is the proper answer? Think about it. The answer is A. When you bend branch of tree, obviously one side of the branch will have tension, the other side will have compression.